Alright, so this is how we're gonna go through this notebook for the session 2 activity. And what we're gonna do is we're gonna use something called a convolutional neural network, CNN for short, to classify images. Now, in this tutorial, we're just gonna use two categories, so normal lungs and pneumonia lungs. And we're going to use a data set sourced from Hugging Face by Paul Mooney. So the way we do that is we're just going to directly download using Python code, but first we're going to install a package called Hugging Face Hub. So what we're going to do is just add an exclamation mark because we're going to access the terminal. This is a terminal command, pip install Hugging Face Hub, and we're just gonna control enter that and to execute. But first we're gonna have to connect to the runtime. If you look to your top right, it has to be a green check mark. Alright, so now that it's connected, it should be able to finish this. Alright, so now it's downloading, so now it's installed. Now we're just gonna import these libraries. We're gonna have to use these to do the rest of the stuff that we're gonna do. For example, we're gonna use PIL to view the images and matplotlib to plot some graphs. We're just gonna download the data set using the library that we just downloaded and installed, Hugging Face Hub. We're gonna download the data set. Alright, so once that's done, what we want to see is, this is optional, but if you want to find out where the .zip file is located in your runtime, just print path to data. Because we define this variable path to data here, and this method here, HFHubDownload, outputs a string, which is the path to the dataset that you just downloaded. So if you print path to data, let's execute that, you will find out where the actual path is. Alright, so extracting the zip file, we need something called the zip file library. This is a library that comes installed with Python. So just write import zip file here and then control enter. So it needs to be imported first before you can use these zip file methods, and now it's extracted. So how do we know the number of images in the dataset? Obviously, you can just open it up and have your file explorer count it for you, but in Python, you can print it out using this code. But first, this code needs two libraries called fnmatch and another library called os. So import fnmatch and import os. So control enter to execute again. And so it turns out we have, almost 9,000 pneumonia images and 3,000 normal images. How do we open an image from the dataset? So this is one of the ways we can do it. So what this does is, this is the path to your dataset, and this is the path to your images. Now we're making a list of files in the pneumonia folder. So right now this is actually the 50th image in your folder. If you want to find out the first image, you just access the first element of the array. Replace 49 with 0. So this should be your first image. This is how it looks like. What about your second image? Just replace it with 1. And there's your second image in that folder. Alright, so we're gonna create our training data. Right now we have to downscale these images because they are kind of large. We're gonna downscale it to 150 by 150 pixels and a batch size of 30 images per batch. So we explained how in the live workshop what batch and epoch means. So essentially an epoch is one cycle of your dataset, and your batch is like the division of that dataset. So it'll be like in batches of 30 images at a time, and then we're gonna update the weights, and then we're gonna downscale the images to 150 by 150 pixels. Alright, so just execute these code blocks to set up your training and your validation sets. So we're going to use a 70 to 30 split, so 12,000 files in total. So 8,000 for training and 3,000 plus for validation. And now we're just going to execute these as well. And we're going to have two classes, normal and pneumonia. So these are some of the images and their corresponding correct labels in the dataset. So again, we're going to use matplotlib, which we have imported at the beginning of the notebook. And so these are just some of the normal and pneumonia x-rays. All right, so how do we optimize the dataset for training? You can read more about this in the TensorFlow documentation, but we're just going to skip over this. But basically, when we train, there's some stuff that you can do to help it train better. So these are just some memory management, how much data you're going to put in your RAM, how much you're going to cache it as a temporary file in your disk. But yeah, we're just going to skip over this detail right now. Okay, so this is an important part. Normalize your channel values. So in your image, each color pixel is represented by 3 integers. Each represent the contribution of each color channel, red, green, and blue. And so each of those integers span from 0 to 255. So the point of normalization is we want to scale it down to a smaller range. So instead of from 0 to 255, it's 0 to 1. And the more theoretical reason why we need to do this is because it actually converges faster if your values are smaller. So we're just going to copy this, all right? Copy that, Control C. And then we're going to go here, okay, Control V. And then at the end of this, you need to put a comma. This is important. So this is actually your definition of your entire network. These are all your layers. Now again, it's more technical how we're going to use these layer functions because it needs a lot of explaining to do. So right now we're just going to skip over this detail. But essentially, since we're using a CNN architecture, we're going to use convolution layers. Okay, so now we're just going to compile the model. And this line of code will determine what kind of optimizer you use and what kind of loss function you're going to use. So in this case, we're going to use something called cross-entropy loss function, which is optimized for image classification tasks. All right, so this line of code is going to print out your model summary, all of your parameters in each layer and your total parameters. So we're going to have 2.6 million. And now, finally, we can train the model. So here, this is where you're going to define your epoch. So that is the amount of times you go through your entire data set. So we're going to go through the entire data set 5 times. So this should take no more than 2 minutes. If you look closely, your loss and accuracy function is going to be updated real time. All right, so now it's done. So how do we analyze how the model does as it trains? So just execute this line of code, and what you will see is as you train it, so these are epochs and your training and validation accuracy. So your training accuracy, which is your blue line, increases obviously, and your validation also increases. And your validation loss is just the same function, but it's a downward trend. So this is what you should expect, because if you're just training it for a single epoch, you might not have the best validation accuracy. What you want is your model to have an optimal training accuracy. So when it eventually processes the real world x-rays, it's going to be able to determine whether it's a normal or a pneumonia x-ray more accurately. So how do we predict on new data? So we can actually find an image online. So let's go to Google Images and find, let's look at a normal lung x-ray. Yeah, this is a normal chest x-ray. So it depends on where your computer saves it, but we're gonna upload this. So just click on this button here and then click on this thing here. This is for uploading, and just locate your pictures. So this is what we got. So just wait for it to upload. So how do we find the path to this uploaded image? Because right now it's been uploaded to our runtime. So just hover over this And once you see these 3 dots, click on those 3 dots and then go to copy path. And right now it's copied to your clipboard. Now replace this sentence blah 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 and paste. Don't forget these quotes, because in paths we represent them as a string data type, so it's important to have these quotes. So right now we just actually we can add a line of code. So pil.image.open path to predict. So this is gonna open that image and show it here. So I just execute this line of code. So it's 93% likely to be normal, and it was normal. So yeah, 93% is a reasonable accuracy. So it's not overfitted. But this is actually just one image. What you should usually what we do is we have our own testing data set, and we automate all of the analysis. But right now we're just gonna do this for fun. Just find whatever X-ray you have on Google Images. Okay, where did we get? How about this one? This is from pneumonia caused by COVID. Let's see. Let's take a screenshot of that and upload it. Uploading. Now we do the same thing again. Hover over it, click on these 3 dots, click on copy path, and then you just go over here and replace your old path, and you just paste it there and execute it again. Let's see. It is 100% likely to be pneumonia, and again, this is very confident, but it is the pneumonia X-ray that we just got. So we have a pretty decent detection model here, and I hope you've learned more about computer vision and how we do machine learning with TensorFlow. Thank you.